Good morning, good afternoon, and good evening, everyone. Dear authors and distinguished guests, welcome to Technical Session 12V. I'm Sanskriti and I will be moderating this session today. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, that is ICTIS 2026, being hosted in Bangkok, Thailand. This 11th edition is being conducted in a hybrid mode. The physical conference took place yesterday in Bangkok, while the virtual sessions are being conducted via Zoom from 9th to 11th April. I hope you find today's session insightful, engaging, and intellectually enriching. In this session, we have 10 presentations. Each presenter will have 10 minutes for their presentation, followed by 2 minutes for Q&A. A gentle reminder will be given at the 8-minute mark. All participants are requested to remain connected until the closing remarks. For any queries or updates, please use the chat box. Now, before we begin the session, I would like to introduce you all to our session chair, Dr. Ganesh Regular, who is an associate professor at Vardhaman College of Engineering, Hyderabad, India. He's an active member of the Soft Computing Research Society, that is SCRS, and is listed on Google Scholar. His research interests include software engineering, image processing, and database management systems, with active involvement in teaching and research. Welcome, sir. Would you please like to share any opening remarks with us?
Thank you, Sanskriti. Let's start the session so that we can conclude as early as possible because I have to close it by 4 o'clock. And best of luck, all the participants.
Sure, sir. First up, we have Venkata Sasidhar Komu presenting the paper titled A Hybrid Deep Learning Based Intrusion Detection System with Enhanced Feature Optimization for DDoS Attack Detection.
Hello.
Hello, Venkat. You may please start your presentation.
Excuse me, ma'am. Can I make a request? Like, I have an internet issue. Is it possible to postpone by 10-15 minutes? Like, can I go second or third?
Okay, sure.
Thank you, ma'am. Like, I am currently in my village, so I'll just give me 10 minutes. I'll set it up.
We will be moving forward with the next presentation. Our second presenter is Amulya Saxena, presenting the paper titled A Topological Framework for Human Bot Classification and Social Networks Using AutoML Optimization.
Good afternoon, everyone. I'll just share my screen. Is it visible?
Yes.
Okay. So, good afternoon, everyone. My name is Amulya Saxena. Today, I'll be presenting a research paper titled A Topological Framework for Human Bot Classification in Social Networks using AutoML Optimization, authored with Dr. Pratibha Joshi and Dr. Advitya Sinha. So, just an introduction. Social media allows information to spread, often spreads faster than verified information. This makes it hard to judge what is trustworthy. Also, bots behave differently from humans in how they interact and connect within a network. So, behavioral signals alone are not always reliable, but network structures give more stable patterns. So, there is a need for a unified approach that combines both of these for better large scale detection. So, previous research shows that misinformation spreads quickly, especially when it gets early attention, which makes it hard to control later on. Over time, studies have shown that network structure is very important, where a user's position and connections influence visibility more than the content itself. Also, bots are also found to occupy different structural roles in the network. Also, some work highlights coordinated group behavior of bots, and overall, structure-based methods are more reliable than content-based approaches across different situations. So, most of these existing methods, they mainly focus on content or individual user behavior, and they often don't perform well when the context or domain changes. They also fail to compare how users interact within the network as a whole. So to overcome this, we propose a unified approach that combines both behavior and network structure. Here, the structural patterns are more stable, and coordination among the users can help identify bot groups, which make the model more reliable and scalable. So, for the study, we use the 2eBot22 dataset, which contains labeled human and bot accounts along with their interaction network. To make the analysis computationally feasible, we reduced the network using sampling and removed unlabeled users while still preserving the overall structure. It is also important to note that the data set is imbalanced with more human accounts than bots, which makes the classification task more challenging. So here we compare the structural features of humans and bots, such as closeness, harmonic centrality, average neighbor degree, and eccentricity. Overall, the distributions look quite similar, but there are still subtle differences between the two. Bots tend to occupy slightly different positions in the network and often interact within more repetitive or tightly connected groups. These small but consistent differences show that structural features can help differentiate bots more effectively than behavior related signals alone. So, here we look at how different structural features. Are related to each other for humans and bots. Overall, the correlation where human accounts generally show slightly stronger correlations between features as compared to bots. So this shows that using multiple features together gives better insights than relying on just one metric. So here we observe the degree distribution of human and bot accounts. Both of them follow a very similar pattern where most nodes have low degrees and the frequency gradually decreases as the degree increases. The distributions mainly overlap across most degree values, which shows a strong similarity in the overall structure. However, there are still slight differences across the range where bots tend to have a marginally higher presence at lower degrees. This shows that there are subtle structural differences, even though the overall patterns remain quite similar. So here we show the validation accuracy of different models trained using the AutoML framework. We can see that we achieved high accuracy very early, and most models quickly reach similar performance levels. After that, the improvement becomes very minimal. This early convergence indicates that the structural features already capture strong predictive information, which lead to stable and consistent performance across different models. So here we look at how stable the models are by comparing their accuracy loss with the best performing model, which is light GVM. Most models show very small differences, which means that their performance is quite stable. This shows that the important predictive information is already captured by the feature set. We do see a few spikes for weaker models, but overall it gives a small improvement by combining these minor differences. So here we compare both performance and efficiency of different models. The accuracy remains very similar across models with a slight decreasing trend showing strong convergence. This indicates that the features are more important than the model complexity. Light GBM achieves almost the same accuracy but with much lower training time, giving the best efficiency. It is fast, lightweight, and more suitable for scalable and resource-constrained deployment, which makes it the most practical choice among all models. So to conclude, this work shows the human bot classification. It shows that human bot classification can be effectively done using network structural features along with an AutoML framework. We observed that humans and bots show subtle but consistent differences in their network properties. The results also show that simple models like LightGBM can achieve near optimal accuracy while being highly efficient. In the future, this approach can be the references that we use. That's it from my side. Thank you.
Yeah, Amulya,
Yes, sir.
am I audible?
Yes, sir.
Yeah. First of all, which data set you have used? So from where you got that data set?
So this data set is called as Speedbot 22. It is an open source data set and it is available on GitHub. This is the
What
link.
features, what features or what parameters you are taking from that data set? In what form you are taking that?
So the data was present in the form of network, but in a CSV format, and we were given the node values, the value for each node, and its label, whether it is a bot or a human, and some of them were unlabeled.
Okay, how does your proposed topology framework combined with AutoML optimization enhance the accuracy of human bot classification?
Yeah, so there are already multiple frameworks that can classify from a network dataset what it predicts. So AutoML, it is a combination of multiple such frameworks, and among them we find that LightGBM was the most effective one. Yeah, this one. So these are all the models which are there. AutoML is basically it combines all of these models, and all of these models, they work on the entire data set, and then they predict which is the most reliable one.
Yeah, that's it from my end. Good presentation, Amulya. Good, keep it up.
Thank you, sir.
Thank you, Amalia, for your presentation. Next, we have Arun Bansal presenting the paper titled A Transparent and Resource-Efficient AutoML Framework with Agentic Guidance and Meta-Heuristic Feature Selection. Arun, you may start your presentation. Arun Bansal, are you here with us? We will be moving forward with the next presentation. Next, we have Harita Venkatesan presenting the paper titled An Intelligent Strategy Simulation Framework Using Telemetry Data for Time-Dependent Decision Optimization.
Hi, ma'am. Can you hear me?
Yes, you're audible.
Okay, 1 second. Let me share my screen. Ma'am, can you see my screen?
Yes, it's visible.
So good afternoon, everyone. I'm Harita Venkatesan from RV University in Bangalore. Today, I'll be presenting my work on an intelligent strategy simulation framework that uses telemetry data to optimize time-dependent decisions, which I've demonstrated through Formula One as a case study. Okay. So coming to the motivation of my problem, in many real-world systems, whether it's manufacturing, logistics, or motorsports, performance degrades over time and decisions have to be made under uncertainty. The challenge is that most existing work treats degradation modeling and strategy evaluation as two separate problems. There's no unified framework that combines both. That's the gap of this paper. That's the gap this paper addresses. Okay. So my paper makes four main contributions. First, a data-driven framework for modeling degradation using both regression and neural networks. Second, a simulation engine to evaluate strategies with intervention penalties. Third, a comparative analysis of those two model types. And fourth, the framework is fully generalizable beyond motorsports, which I'll come back to at the end. Okay, so the data set. The data comes from the Fast F1 Python library, which provides real Formula One telemetry data. We use race data from the for this case, we're using the race data from the 2019 season, specifically a two-stint strategy, medium tires for laps 1 to 14, then hard tires from lap 15 to 58. Pre-processing involves removing pit laps, segmentation stints, and computing degradation age. The number of laps, degradation age is the number of laps elapsed since the last pit stop. Okay, so the framework. Here's the overall framework. It has 5 stages. Raw telemetry goes in, features are engineered, a predictive model estimates lap times, and a simulation engine evaluates strategies. And the output is a quantitative ranking of alternatives. Importantly, the design is modular. Any component can be swapped out independently. Okay. For modeling, we use 2 approaches. On the left, linear and polynomial regression. They model lap time as a function of degradation age using this equation. They're interpretable and serve as our baseline. On the right, a feed-forward neural network with ReLU activations trained using mean square error loss and the Adam optimizer. The neural network can capture nonlinear patterns that regression simply cannot. Okay, the simulation engine works in 4 steps. We define a strategy as a sequence of stints and pit stops. We then use our model to predict lap times. Each pit stop carries a time penalty. And finally, a cumulative race time is accumulated across all laps. This lets us compare any 2 strategies under identical conditions objectively. So looking at figure 1, the degradation curves. The medium compound shows stable lap times initially, then a gradual rise over its 14-lap stint. The hard compound covers 44 laps and shows a slower but consistent increase. Importantly, both curves deviate from a straight line in the later laps. This non-linearity is exactly what motivates using neural networks. Okay, so table 3 shows the key results of for model performance. And yeah, you can see that the neural network achieves a MAE of 6.17 compared to 7.87 for linear regression. That's a 21.7% improvement, and RMSE drops by 14%. Both confirm that the neural network better captures the complex degradation dynamics present in real telemetry data. Okay, so figure 2 shows cumulative race time for the actual strategy versus a single pit stop strategy. The lines track closely at first, then diverge sharply at the pit stop lap. That time, penalty creates a permanent offset that is never recovered. Table 2 confirms this. The actual no pit stop strategy finishes in 5,267 seconds, while adding 1 stop costs 44 seconds and 2 stops costs 66 seconds. Okay, figure 4 makes this even clearer visually. More interventions consistently result in worse total race time. The key insight is that optimal strategy is not just about minimizing tire wear. You must also account for the penalty cost. Heuristics that ignore this will consistently underperform. So to conclude, the framework successfully integrates predictive modeling with strategy simulation. Neural networks outperform regression for degradation estimation, and critically, strategy timing matters as much as raw speed. More pit stops does not mean better performance when penalties are factored in. Yeah, thank you.
Yeah, Harita.
Yes,
First of all, nice presentation.
yes, sir. Thank you, sir.
Any questions from audience? If anyone to ask any question? Okay, Harita.
Yes.
What is the use of regression as a baseline as far as your problem statement is concerned?
So basically, we're using regression for better interpretability. Suppose, like, if you look at neural networks, then it's really hard to interpret and things are hidden. So it's mainly used for interpretability.
And how does the core framework use of bidirectional cross-modal imagination networks with the cycle consistency constraint? improve the stability of multimodal prediction when certain modalities are absent.
Sorry, sir, I didn't get your question.
Okay, what is your title?
My title is Intelligence Strategy
Telemetry.
Simulation Framework. Yes, sir, using telemetry data.
Yeah. What is that telemetry data? How you'll get that telemetry data?
Sir,
What do
so
you mean by
in
that?
my yes, sir. So in my case, I've used Formula One telemetry data that is available as a Python library. So yes, sir, it consists of driver names and then driver lap times and what tire they're using and stuff like that, which I've taken into consideration.
Okay. Okay, Harit. That's it.
Yes, thank you, sir.
Thank you for your presentation, Harita. Up next, we have Aditya Dinesh Netrokar presenting the paper titled Automated Answering Sheet Evaluation System.
Hello, is my voice audible?
Yes, you're audible.
Yeah. So, just let me share my screen. The slides visible?
Yes, it's visible.
Hello. Yeah, sure. Thank you. Hello everyone. Myself, Aditya Dinesh Netkar. I'm currently in fourth year computer science department, BMS College of Engineering. So, this is my project, automated answer sheet evaluation. So overall, this is the project where we can automate the test answer sheets and provide the marks accordingly. So, with the rapid advancement in the technology, so there has been a major impact in the education sectors also. So when it comes to the evaluation of the answer sheets, so most of the time it has been done manually. So as a advancement in the technology has been seen, we can automate that part also. So we can implement it using NLP as well as neural network, from which we can automate the grading so that the teachers can be more can dedicate more time to the teaching and less on their administrative duties. So the current problem statement, the issue that we are facing is the manual answer sheet based evaluation is time consuming, especially when it comes to subjective answers. So a teacher has to face a lot of challenges when there is a large volume of answer sheets. So as the time passes, there may be some difference in the grading of answers between different students. And also, the perspective may change between different teachers. So, by automating so instead of having automated your evaluation system, we can ensure there is a efficiency, accuracy, and also we can have a proper feedback we can have a proper response to the students' answers. So, the main objective of a system is first to develop a neural network model which will understand the handwritten text and increase its accuracy in the recognition, and also create an NLP algorithm so which will understand the answers written by the students, and also as well as creating a user-friendly design which will be easily understood by the teachers, and they can follow the evaluation tests with ease. So our project integrates with many of the sustainable development goals, where it has played a major impact on the quality of education, which helps to have a enhancing responsiveness, and also it decreases the burden for the teachers, as well as it has a application in the sector of industry innovation also. So hence there has been use of the advanced technologies here. So, in order to get the data set for this project, we have collaborated with a university where we approached one of our faculty to get the real uh, the test papers of one of our internal assessment through which we have through which it has been taken as a data set and and help to raise the educational practice and encouraging use of technology. So let us now understand how this system actually works. So here, let's think of a scenario where a teacher will log in and they can upload the model answer paper as well as the scanned answer sheets. The scanned answer sheets are the one which are the student written test papers. So those papers will be pre-processed and there'll be a text recognition done under the CRN model and later the uh, answer checking phase come into action where we will use the NLP model. So it will semantically understand the answers and it will compare between the model answer paper and it will assign the marks accordingly and the database will be stored. We have used the MongoDB here. Here, the teachers can view the student answers and also like in the initial stage, if the teachers feels that the marks predicted may not be right, they can either edit the answers and and they provide the results there. So when it comes to the detailed designing, so under the pre-processing, we have gone through stages like binarization, then the line segmentation, noise removal, and also under CRNN model, there are multiple stages like convolution, activation, and there is a pooling and CTC losses. So here we will understand the characters in the form of vectors where whenever there are complex edges in the characters, so hence the CRNN comes into action and it will recognize it with a greater accuracy. And then under the evaluation phase, we use the NLP model where it will the NLP model consists of many parameters like cosine similarity and there is keyword matching, partial matching, and also there is a one more thing called Zenova transformer, which will clearly understand the meaning behind the sentences written by the students, and it will evaluate accordingly. So this is the implementation. You can see here how we have mentioned the parameters. The image in the right. You can see here how we have mentioned the parameters for the evaluation here. This is the UI of our system work. So firstly, the teacher who have logged in must create a course and they can upload any of the upload their model answer sheet and the corresponding students answers. So the results that we have obtained here. This is how we obtain for each of the answers. We get the scores here. So there is a relevance score and the semantic score. And we will run some of the mathematical calculation and we get the final score here. So this is how the neural network has extracted the text. So this is for the answer key. As you can see here, how we the accuracy is almost nearby 90%. So most of the responses that consist of mainly characters, we can recognize it comfortably. But we may face some issues when it comes to mathematical expressions or any diagrams. So here you can see how we can predict the marks were predicted. So if the teacher, as I mentioned earlier, if the teacher feel that the marks were predicted is not satisfactory, they can edit in the future. So this is been used. This feature has been used only in the initial stage. So once the model gets trained accordingly, we can remove this feature as well. So this we have
Excuse
run
me,
a.
Aditya. Sorry to interrupt you. This is just a gentle reminder that 2 minutes are left for your presentation.
Okay, sure. Yeah, thank you. So we have run an analysis here where we have made a marks comparison. So we have taken a set of the test papers. So we have and we have considered the marks power predicted by the humans as well as from the systems. As you can see, most of the time in this graph, uh, the marks are matching, but there are some ups and downs in some of the cases. And also we have achieved accuracy almost nearby 90%, to be precise, 92%. And also we have run uh, uh, some of the testing here. So there is a character error rate. So over the epochs, so we have run an analysis. So at the initial stage, it has been predicted power that there has been lot of errors. So as the model is getting trained, that there has been a very low error rate on the characters, and also you can see the accuracy as well. So as there is a incrementation in the epochs, the model is learning the data set, and it is providing a higher accuracy, and it is reaching up to some point. Hence, I would like to conclude my presentation here. So, our main aim is to reduce our manual workload and increase the evaluation speed. So, all we need to is to automate the part where we require a lot of manual power. So, and also we aim to increase the accuracy on this CRNN model in order to uh, it can understand the characters as well as the mathematical expressions of the diagrams as well. So yes, we have also gone through some references in order to create this model. So yeah, that's all from my side, and uh, I'm happy to accept any questions you have.
Yeah, Aditya.
Yeah. Yes, sir.
Nice presentation, first of all.
Thank you, sir.
Let me ask you a question that how does your proposed automated answer sheet evaluation system is ensure accuracy and reliability compared to traditional one?
Yeah, compared to the traditional one, currently we focused on the papers that were mostly theoretical, that consist of less diagrams, any mathematical expressions. At that aspect, our system has been working really good. So when we compared the marks power predicted with the human along with the system, so it has been same at most of the times. But when it comes to any like uh, a subject which consists of any expressions or any diagrams, so there has been some ups and downs in that side.
Yeah, in theory also, how your system is going to working means you are already providing a scheme that is means answers for that question paper, right? And
Yes.
when it is going to evaluate of the any student answer sheet, so
Yeah.
your given answer and the student's written answer, that is going to be compared,
Yeah.
right? Word to
Yes.
word. So
Both are
it
getting
but
compared.
yeah, both are getting compared, but it is
Yes.
not like that. Whatever written by your system, that is answer sheet, or the
Yeah.
expert system's answer sheet, and the students written the whatever their answer, that maybe language differ. So in that case, how your system is going to calculate?
Uh,
And means
Sorry,
I getting my question that the whatever question is asked, that student written similar to as per that question, as per that question, that student written the answer,
yeah.
right? And you whatever answer you are providing, your answer sheet you are providing to compare
Mhm.
which is written by the student,
Yeah.
right? So it's not like
Yes.
that both should be the same type of words or character, maybe differ.
No, no. The meaning must be same, but not necessarily there
how
must be
how it is
exact.
going to be changed, that meaning must be same. For example, software engineering, so so in your system one particular two lines are written, right?
Yeah.
The definition of
Yeah.
software engineering in two lines it
Yeah.
is written, and the
Hmm.
student written in 4 to 5 lines in his own
Yeah.
language, but that is
Yeah.
also correct. So how it is going to
Yeah.
be checked?
So there, we have mentioned some of the parameters there. like mentioning of the keywords in those answers. So how many times the keywords has been relevant in the student answer? So is that keyword mentioned in the model answer as well as the student answer is the same, and also the answer length is same, as well as the meaning of the answers is same. So in order to understand the meaning of the answer, we have been running a semantic analysis. So basically, it has a transformer called a Zenova transformer, which will understand whatever the student has been written, not the words. So let's take an example there. As you mentioned about software, uh, let's take an example. Let's say a sun is very hot. This is the sentence written in the model answer paper. But when it comes to student answer, so he has written the sun is very high in temperature or sun is very warm. So what will happen is the Zenova transformer will understand that both the sentence have the same meaning, even though the words is getting changed. So yeah.
In case that student is written that today's weather is cool.
Mhm. No, in that way, I think the answer may not be relevant because we need to mention some of the
The
keywords there.
meaning is
So
same,
like
no?
the sun,
Okay. Okay.
yeah, the sun.
Okay. Okay.
So in that, yeah,
Okay. 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 I got it.
yeah,
Okay, Aditya.
yeah. Thanks a lot, sir.
Thank you. Thank you, Aditya, for your presentation.
Thank you.
Next, we have Anfam Nam presenting the paper titled "4 Cross-Modal Embedding Reconstruction for Robust Multimodal Learning under Missing Modalities with a Lumbar Spine case study."
Hi, hello, can you hear me well?
Yes, you're audible.
Okay, so let me just share my screen. You can see my screen already, right? Hello?
Yeah,
Yes,
yeah,
the
yeah.
screen
It's
is visible.
visible.
All
Yes.
right. All right, so good afternoon, everyone. My name is Nameng, and I'm currently a third year university at Ho Chi Minh City University of Technology. And today I will present about a cross-modal evidence reconstruction framework. Our main focus is to maintain the robust multi-model performance when specific modalities are missing, and we will use the numbers by case study for validation. So now let's jump straight in. We know that for multimodal models, they often outperform unimodal because they combine complementary signals. But most methods, they assume all modalities are always available. But in practice, the modalities are often missing due to a lot of reasons. So there are common fixes, such as we can zero mask the missing evidence, we can fall back to use a unimodal. But those methods usually create a training inference mismatch and unstable predictions. That is why our goal is to design a multimodal framework that remains reliable under both complete and incomplete modality settings. We propose CAR, in which it will reconstruct a missing modality evidence before it reaches the fusion stage by using bidirectional imagination networks and applying psychoconsistency. Our core contributions are a unified evidence level framework, a robust inference behavior under severe modality absence, and a real-world validation on a spider benchmark. We are not the first one to look at this problem. Existing research generally falls into these four buckets. And while these are very great foundations, they often struggle with the complexity of real-world clinical data. And we identify three major gaps. in which many methods are tied to redefine missing patterns. They lack explicit semantic reconstruction, and their robustness often degrades under severe data absence. The core position is now right in the middle. We use embedding level imagination inspired by existing reconstruction lines, and we also add the cycle-consistent bidirectional mapping. This will ensure stable influence across both complete and incomplete settings without having to redesign the whole fusion backbone. So now we move to the methodology. This is the heart of our framework. Our pipeline consists of 4 main components: the cross-model imagination networks, the modality dropout, the shared state position together with the fusion transformer, and finally the prediction head. So we will move to each of the components one by one. So first, let's start with the imagination network. Our imagination networks are implemented as procedural MLPs, and first we will project the available evidence into a hidden space where it undergoes several layers of the residual refinement to capture the complex cross-model relationship. A critical step is the final normalization. We constrain the reconstructed evidence to a unit hypersphere. It makes sure that it is mathematically stable and directly comparable to the original data. Well, this step allows us to use Gaussian-based abstraction on to calculate how accurate our imagination actually is. And before we go to the fusion stage, we always make sure that it has completed embedding pair. Is either is the original embedding or the reconstructed one. So when it comes to the transformer encoder, we will see these 3 tokens. The first is the TOS token, and other 2 modality embeddings. The transformer uses special attention to model the interaction between the 2 modality embeddings, and we then only extract the final state of the TOS token to represent the fused embedding vector. So we shift away from standard softmax classification. So instead, we project our fused embedding vectors into a label embedding space. So which means that rather than just picking a category, we have to measure the constant proximity between our prediction and the target labels. And to tie all the components together, we use a multi-objective loss function in which the loss for task will align our prediction with the graph truth. The loss for reconstruction will ensure the imagination networks stay accurate. And finally, the loss for the cycle will provide a bidirectional check. And by enforcing the cycle consistency, we ensure that if the model translates an image to text and back to an image, the semantic information remains stable. This will prevent the model from hallucinating mathematically valid, but medically meaningless data. So to validate whether the pipeline works, we will use a dataset named Spider. This dataset contains of MRI scans, both in T1 and T2 scans. But in default, this dataset doesn't have text, so we have to use a medical element to generate the text for each image, and it resulted in 384 pair MRI text samples. Our task was to classify 13 different medical labels for this. And during training, we will randomly sample among 3 modalities: image only, text only, or full modality. And we will compare our core baseline with the 0 vector matching baseline, in which we will replace the missing features with 0. Here you can see the result when we hide the image. So when we hide the image, the core pipeline remains comparable to zero masking. It shows a very smooth and stable performance equation, especially at 90% of machines. The core pipeline has achieved the higher performance. But the real breakthrough is that when we hide the text, we can see that for the zero masking pipeline, it is better at low mixing rate. But when it reaches over 70% of mixing rate, the core outperforms the zero masking pipeline. So this proves that our editing completion is much more effective than just filling the missing with zero when the text data is scarce. We also evaluate whether if the core emission evidence match the original evidence, and we saw that a minimal performance drop of only
Excuse me.
0.47%.
I'm sorry to interrupt you. This is just a gentle reminder that 2 minutes are left for your presentation.
Okay, I got it. Thank you. And in micro F1, and the record stay the same. This confirms that our imagination networks are capturing the essential semantic features needed for a correct diagnosis. In conclusion, CORE provides a practical editing level path to reliable multimodal, and we've shown that by using bidirectional imagination and cycle consistency, we can maintain high reduction even in the circumstances where the data is poor. And moving forward, we plan to extend CORE to handle more than two modalities and explore uncertainty aware deployment to make the system even safer for real-world clinical decision support. So that's also the end of my presentation. Thank you for your attention. And if you have any question, I'll be happy to hear and answer it.
Okay, nice presentation, I'm fine.
Thank you, sir.
Yeah. How does your core cross-model embedding reconstruction improve robustness in multimodal learning when certain modalities are missing?
Yes, sir.
How does your system improve robustness in multimodal learning when certain modalities are missing?
So we use architecture named bidirectional mapping and cycle consistency. So let me go back to the diagram so I can say it more better. So in most multimodal models, when input is missing, so it just assumes that it will perform zero masking, or it can fall back to use a unimodal model to predict. So for our pipeline, when input is missing, we will try to recreate that input evidence. So we will try to recreate it so that the newly created evidence is as much as the same as the original one is better. So we will fix the problem where we miss the one of the two inputs. So that's how we can increase the robust cross-model multi-model.
So, is your system using all types of what document?
Excuse me, I didn't hear your question very well.
Miss, is your system is using all type of documents, or only structure type of documents, or certain types of heterogeneous document, or what?
You mean that did I base on what document, right? Sorry, because the accent is really hard for me to understand the question.
Okay. What is the use of LLM in your system? Using any LLM? Is there any use of LLM in your system?
Yes, we use an LLM system to generate the text for the spider dataset.
Yeah. For what purpose you are using LLM?
We use the Biomistron 7 billion. It's a model to generate the text, the clinical text for our lumbar spine image.
Okay. Any questions from audience? Okay. Okay, dear.
Okay,
Thank you.
thank you for your question. Thank you very much.
Thank you, Anne, for your presentation. Next up, we have Atul Anil Kumar presenting their paper titled Automating Diabetic Retinopathy Grading through a Hybrid Deep Learning Model.
Am I audible?
Yes, you're audible.
Is the presentation visible?
Yes. Yes.
Yes.
Please continue.
Okay. Good afternoon, everyone. I'm Atul Anil Kumar. I am presenting the paper ID 510, Automatic Diabetic Retinopathy Grading through a Hybrid Deep Learning Model. I myself and my colleagues, Dr. Deepa V and Dr. Sheena Susan Andrews, together have done this work. Going into the contents of today's presentation, we have introduction, problem statement, objectives, proposed system, data, description and sources, architecture, methodology, result and comparison, insight limitations, conclusions. So as an introduction, diabetic retinopathy is a progressive retinal disorder that is caused by prolonged diabetes and which leads to microvascular damage in the retina, which if it is left untreated, it can cause irreversible vision loss, blindness, and significant damage to the organ. So the traditional method, an ophthalmologist examines fundus images, which is subjective and time consuming. So the recent advancements in deep learning and computer vision has enabled automated, scalable, accurate screening systems. And our literature on existing systems show that there is a mix of CNNs that is being used and also models which use transformers also. But we observed that there is a lack of hybrid systems that makes use of these two models. So going into the problem statement was to address the lack of a reliable detection and grading system for diabetic retinopathy. So in the model development, our objective was to develop an automated multi-class diabetic retinopathy grading system, which classifies into healthy, mild, moderate, and PDR, which is proliferative diabetic retinopathy, and leverage the advantages of these two models and apply dimensional reduction for the efficiency of the model and benchmark the hybrid model against individual models using accuracy, precision, recall, and F1 score. So, as we said, the gaps in the existing systems show that there is a use of CNNs, transformers, but the combined use of and the advantages of these two models are missed here. So, our proposed system uses the efficient B7, VIT B16, and the complementary feature sets are being used here. So, I will explain those in the upcoming slides also. So, as a dataset description, we have 4 classes: healthy, mild, moderate, and PDR. So the image representations are given here, which shows a healthy, mild, and moderate and PDR conditions of the retina. So those are the clinical markers that the model will be using for classification. As data sources, we had to not only rely on public data sets, we actually went on to have a clinical data set obtained from Bharat Hospital, Kottayam. So, and that has been incorporated into a combined data set of dataset from Kaggle DR detection dataset, STAR dataset, DIRET DB0, DIRET DB1 dataset, and ROC retinopathy online challenge dataset for microaneurysms also. So in the dataset distribution, we have roughly equal distributions in all these classes. In healthy, we have 575 images. Mild, we have 575 images. Moderate, we have 570 images, and PDR also we have having 570 images. So this is the architecture of the model. There is input data. Data pre-processing is being carried out here, and the models, the ensemble models are shown here. So the efficient B7 is on the left side and the VIT on the right side. and the feature vectors are being combined here. Okay, so and the combined feature vector is being performed a dimensionality reduction and then passed on to a fully connected classifier for classification purposes. So talking about the EfficientNet V7, it is the largest of the EfficientNet family, and it has roughly 66 million parameters. Looking into the application of EfficientNet in diabetic retinopathy, it is good at observing the fine details in an image. So diabetic retinopathy detection is very hard because in the mild cases and moderate cases, the features are very small and the edges and the texture has to be detected very accurately. So Efficient has an advantage in that regard. And VIT B16 is a patch 16 model which we have incorporated. So the input image we have divided into 16 by 16. So the patch size is 16 here. And the benefit of VIT here is that it has a benefit of having a global logic as well. So the global features are not missed while considering the local features also. So the larger picture is also understood by the model. So the pre-processing technique, the methodology, I'll talk about the image acquisition. As I said, we have collected the dataset from the different sources and we have performed client to standardize the dataset. And it is resized into 224 into 224 size pixels and data standardization performed and training validation split of 80 to 20 ratio is being used here. And also one more thing I'd like to mention is that in the testing, we have actually went on to do a 5-fold cross-validation as well. So methodology of the hybrid feature fusion, it is a standard feature fusion. We have actually combined the feature vectors into the different features, different feature sets from the two models into one. And then the feature reduction is carried out by a linear projection layer. So it actually learns the different features from these two feature sets and combines into one reduced data set of the dimension size of 678 here. And then a fully connected linear classifier is used for classification. So our experimental setup was the framework was in PyTorch and the hardware we used for is an NVIDIA DGX Station 800 of 160 GB of VRAM. These are the evaluation matrices that we used, accuracy, precision, recall, F1 score. And in the results and comparison, I can see that the hybrid performs better compared to the standalone models, as we can see of 92.5% of accuracy, precision, recall, F1 score also sitting in the same area. This is the confusion matrix. And in the limitations we have observed is that the most number of misclassifications occurred in the mild and moderate boundary, which is explained by the linear projection because the dimensionality has to be reduced and also more research has to be carried out for better outputs. So in the conclusion, I'd like to mention that our model has performed considerably better compared to the standard models and compared to the literature that we have referred. So it can be useful in early and accurate diagnosis, and it can be scaled into a better model in the future. So in the future, we'd like to perform advanced cross-feature fusion, multi-center data set validation also, and GradCam and explainability can also be used here. So these are my references. Thank you.
Yes, Atul.
Yes, sir.
Okay, nice presentation.
Thank you, sir.
What features you are taking from that data set for B7, B16 as well as the hybrid model, right? You are saying that you
Yes.
when you are giving the when you are going with the hybrid, you are getting the good accuracy.
Yes.
Right. So what features you are taking from that?
So the features is that the B7 is actually better at looking at the fine details that are very hard to pick in an image. So it captures
Yeah.
a very fine edges, textures in the image, and that is fetched by the B7. And the VAT B16 is very good at looking at the total picture. Okay, so if the vessels are going the right way, or if there is any microaneurysms or vascularization, new formation of vascularization, that is new vascularization, as we can see here, there is new, very cluttered number of vessels that are formed there because the vessels already existing are already damaged. So this kind of logic, it is better by the VAT B60. So there is a mix of fine details and also the global logic as well.
How does your hybrid deep learning model improve the accuracy of that system as compared to the traditional approaches or whatever the existing one?
Yes, sir. The existing works actually focused. I've mentioned that CNNs are mostly being used there, and also VATs are also being used there. But a hybrid model, there is a lack of hybridization I observed in the literature, sir. So the hybridization actually performed better in the research in our experiment. So we are looking to work on it more in the future. Sir.
Okay, good, Atul. Thank you.
Okay, sir.
Thank you, Atul, for your presentation.
Thank you.
Now we have G. Naga Sri Suma presenting the paper titled Wireless Implanted Devices for Arrhythmia Detection and Management, a Technological Overview. You may start.
Ma'am, am I audible?
Yes. You are audible, Nagas.
Yes, ma'am.
Please start your presentation.
Ma'am, yes, ma'am. Ma'am, can you able to see my screen, please? Please let me know.
No, your screen hasn't been shared. Nagasri, please share.
Yes,
your
ma'am. Yes,
screen.
ma'am. Ma'am, is it visible, ma'am?
Yes, it's visible. Please start.
Okay, ma'am. Thank you, ma'am. Namaskaram to everyone. Myself, G. Nagasri Suma. I'm a research scholar of the Department of Instrument Technology, Andhra University, Visakhapatnam, Andhra Pradesh, India. Myself, I have been chosen completely a biomedical instrumentation topic, which is going to be on wireless implant devices for arrhythmia detection and management. My area of interest is on rhythm of the heart, where every beat is a note and every interval is a pause, called as a cardiac signal. As we are aware of heart, we have come to know that it is going to be having two chambers with four walls, which is going to be continuously giving up with systolic and diastolic pressure, creating a frequency, amplitude, and time interval. So any of these are being giving or distracting of any signal, causing a condition so-called as arrhythmia. So how to detect and how we have been completely come to go for the management of this signal and all, we should come to know about the group of conditions which have been causing here for this arrhythmia. So the major causes which we been coming under is heart disease, medical conditions just like hypothyroidism or thyroidisms or imbalance in the electrolytes, or it is going to be affecting with any pneumonia or lifestyles which is going to be changing or any kind of stress causes the arrhythmia. So how could able to identify these are the symptoms which we can able to find here is of shortness of breath, chest pain, tightness, and lightheadedness or dizziness, weakness, fatigue, sweating, anxiety. These are the symptoms which we can able to be identified in the distraction of the signal which has been obtaining in the depolarization and repolarization of electrical activity of the heart. So there are the conditions which we can able to be identified here as three conditions where we can go for us. One is with either the heartbeat is too fast, too slow, or premature. So one is going to be having condition as bradyarrhythmia, where the heart giving us a less pulses, which is going to be less than the 100. And tachyarrhythmia is going to be a more than of 100, is going to be giving a bits per second. And premature is going to be giving us early effects, which is causing here the changes in the atrium and ventricle of the heart. So in my case studies, I have been gone through it. Sinus bradycardia and atrial and ventricles and premature are going to be giving different types of stages of first degree, second degree, third degree, and all in the atrium and ventricle, as well as in AV node. So these three are which are these factors which are being affecting here for a patient to cause a heart failure. So these are the conditions which I have been gone through. This is just a normal heartbeat. Tachycardiac is where we are having is a heartbeat more than which is going to be having greater than of 100, and it is very having a bradycardia which is less than 70. It is going to be having a fibrillation in the atrium, and with respect to the fibrillation, ventricular fibrillations. So in my case studies, when we have been gone through this, the evaluation of implant devices has been gone through a progress through several key stages of this kind of different stages of heart rhythms. So they finally have been decided that the pacemakers is going to be giving us a best among all that. So they have been gone through a small devices which can be placed in the chest and through veins which is going to be delivering the electrical impulses, and they can be able to cure for bradycardia, but it is of completely for only low signals. But what about the higher signals? They have been gone with the same, just like a ICD called as implanted cardioverted defibrillators. So the next one which we have been having with the for premature. So which is going to be having atrium as well as the ventricular, which is going to be having completely distraction of the signals before only it is going to be affecting. So that kind of sickness can be early stage, it can be identified and can be overcome by CRT. So these are the three ways we can go and implement it. But the latest stage which we can be able to identify is not only a single chamber is going to be affected, it is going for two chambers or triple chambers. What is the effect of the patient? It is going to be affected to any kind of the signal can be normalized or not. Then the pacemakers has been gone for single chambers, dual chambers, and triple chambers pacemakers, where different leads which have been placed in different kinds of zones of atria and ventricular, and they've been identified here with the good accuracy and precision that each the signal can be easily monitored. Then there is some kind of impacts which are being affected here, which is causing some kind of discomfort and inconvenience for the patient. So keeping these kind of stages which have been to be overcome and all, they have been gone with the wireless communication methods with the RF telemetry. So similarly, just by implementing this kind of implant communications only, they have been gone with the radio frequency, and that devices can be operated by the outside of the person, and they can be overcome this kind of uh, comfort, and they can bring the comfort to the person. But the impact of here is that there's kind of a limitations which we can able to be identified as this range. What we have been taking here is completely 402 to 405 megahertz of this frequency we have been chosen. It is very low communication range, and it cannot be implemented for person to go for monitoring, and the baud rate or the data rate is also very less, and the power constraints are going to be one of the factors which are going to be affecting to the RF telemetry. And the cost of it is, when we are going to compare with the other pacemakers, it has been high. So next method they have been implemented here is inductive coupling. The same thing, they have been implemented with the non-invasive communications. They have been given with a lifespan where we are going to extend our batteries. So that this is also being affected here only for the shortest range. Then the next case studies, they have been gone through the Bluetooth of low energy pacemakers. So these devices are completely minimized trans receivers. So basically, when we are being having with a low sleep mode, means when a cell is in a resting state, it is going to be in a polarized state. So at that time, the heart rhythm cannot be able to be taking up the QRST waveform. So those such devices can also be cooperated with a blue tooth low energy, which is going to be having here with a better efficiency, which is going to be following up with a Gaussian free frequency shift keying modulation. So these are going to be sending up a packet of data to the patient, and it is going to be controlling the commands, and it is going to be depending upon the stage of the person, it is going to be operated. Next, the same thing which is going to be having with the blue tooth and all. So we will be having here with the internet. Next stage of which technology has been evolved is with the narrow band technology, which is going to be having Internet of Things, which is going to be having with the wide area network with the low power standards and all. We have been implemented, and the data storage can also be helpful for the futuristic, which where we can able to be monitor and helpful for the patient to overcome. So in that area of that, they have been introduced with the IoT technologies. Then during this all, they have been gone through that. This is going to be completely depending upon the power consumptions of the battery. So that is one of the basic, which is going to be increasing the cost of the devices, where even the patients cannot be afforded. So they have been gone through the energy harvesting pacemakers, which is going to be depending upon the piezoelectric, thermoelectric, and inductive energy transfer, electromagnetic, and ultrasonic. These are the methods where the self-sustaining power mechanism can be eliminated, the need for the frequent battery replacements, and ensured long term. So these are the way we can able to be identified that each of this is going to be depending upon the physiological data or the body movement or any kind of muscles or interactivity or any kind of that communication can be established between the patient and the battery, which is going to be giving us information that this signal is being required. So according to that requirement, the signal can be modulated. So here we can able to see this, but still we can able to identify that the extent of battery consumption is very less. So they have been introduced with the low power electronic pacemakers. This ultra low
Yes,
power
ma'am,
electronics
Namaste.
completely with the extendable battery size and implanted with a completely a small size, which is going to be helpful for the patient for the discomfort and inconvenience. So the spontaneous and continuous monitoring
Nagashri,
is
I'm
also good.
sorry to interrupt you.
Yes, ma'am.
This is just a gentle reminder that 2 minutes are left for your presentation.
Oh, okay, ma'am. Okay, ma'am. Only 2 minutes. Thank you, ma'am. I will be completing that. So, spontaneous continuous monitoring we can be able to be identified here. But the thing is, here is also the computational power or any kind of challenges which has completely with the cost of it. Then AI has been introduced with the remote monitoring pacemakers, where the sensing and data collections can be easily identified, and with the wireless telemetry systems and with the cloud management or any kind of internal interferences or alerts on patient interactions also going to be additionally added here, which is going to be giving us completely early detections and complications. So reduce the hospital visits and enhance the patient outcomes and all. So this is going to be a fetch for the coming generations to be completely implemented. These kind of technology means can be helpful for the people. But in the advanced to this, we are going with examples of these industries or the researchers are being completely indulged with the Medtronic or Biotronic or enhanced ECG analytics. Google and Verify and deep learning cardiac models are being introduced, so that it is going to be giving up with the difference within the conventional pacemakers and the AI remoting pacemakers. So we can have the parameters when we have identified previous conventional methods can be overcome by the AI methods. So by using this AI or deep learning methods of this any algorithms which have been having with a hybrid model and all, so we can able to detect arrhythmia, heart failure, or battery optimizations, or any kind of pacing algorithms or anomaly detections. So these applications can be introduced for all to detect and to give the better improvement for the pacemakers. So these has make case studies of references papers which I have been gone through it, and I concluded that these methods have been helpful for my futurist paper. Thank you. So any queries?
Uh, okay, Suma, nice
Sir.
presentation.
Sir.
Uh, okay, how your system, that is multi-layer federated trust framework, enhance privacy preservation and trust in social media interaction?
That's what, sir. We can able to go through the cloud management service and all. Definitely, it is going to be giving us a difference in the conventional pacemakers where we used to use in remote monitoring of telemetry, or else any kind of root and all. Data security, which is going to be having here, is completely in the AI integration. We can able to overcome, sir. That's why we have been
Yeah,
choosing
you are
that.
you are saying AI. AI means
Yeah.
what? Any specific
So
method
this
or
is
any
my
specific
technology overview, sir. Then the next paper
overview?
is
Yeah,
going.
yeah, yeah. Again,
Yeah,
in that
the
you
next
might be
paper are
study
going to
something,
go
right?
for which method I can able to protect the data as well as
Hmm.
patient comfort and all, and how well we can able to detect early, and how well we can able to conclude these complications and all. That is my next paper, sir.
Okay. Is it works real time? It will be work real time?
Oh yes, sir. I'm working on it. I have chosen DL, sir.
Yeah,
Data deep
because
learning. Yeah, deep
definitely there
learning.
will be a question that in what ways do peer review based scoring and anomaly detection contribute to identify the
Uh,
your malicious users in real time,
sure, sir.
right? So that question will be definitely, it will arise. So best of luck. Good,
Yeah,
good
thank you, sir.
presentation.
Thank you,
Keep it up.
sir.
Yeah, yeah.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, Nagastri, for your presentation.
Thank you, ma'am. Thank you so much.
Now we have Venkata Sasidhar Kummu presenting the paper titled A Hybrid Deep Learning Based Intrusion Detection System with Enhanced Feature Optimization for DDoS Attack Detection.
Yeah, thank you, ma'am. Is my audible? Is my audio coming, ma'am?
Yes, you're audible.
So I'll be sharing my screen. So, is my screen visible, ma'am?
Yes, it is visible.
Good afternoon, everyone. So, I'm Venkat Komo, and today, on behalf of my co-authors from Amrita Vishwavidyapeetham, I'm honored to present our research, a hybrid deep learning-based intrusion detection system with enhanced feature optimization for DDoS attacks. So, as we move into 2026, the proliferation of IoT devices, now exceeding 42 billion, has created a massive digital attack surface. In late 2024 alone, we saw a 53% increase in DDoS attacks compared to the previous years. Traditional signature based systems are failing to keep up with these evolving polymorphic threats. Our work addresses this by proposing a lightweight, hybrid deep learning architecture designed specifically for high intensity IoT environments. So, the challenge with the existing machine learning approaches is twofold. They often require a manual feature engineering and struggle to capture the complex spatial and temporal dependencies. For the first step, as our first step, we need to choose a data set which suits our problem statement. So, for our evaluation, we have utilized the CIC DDoS 2019 dataset. This is a benchmark for realistic DDoS simulations, covering 11 different attack types across reflection and exploitation categories. To simulate a true high intensity scenario, we have our testing was designed with an 83.2% malicious traffic ratio, which signifies that we have used more samples for testing. And when we come to our proposed methodology, we have used a hybrid feature selection as As we say, efficiency is critical for edge deployment. Therefore, our first major contribution is a two-phase hybrid feature selection approach. For the phase one, we are using information gain to evaluate the entropy reduction, narrowing the field from nearly 80 plus features to the top 30 features. And in the phase two, we have implemented a dynamic particle swarm optimization PSO, dynamic PSO algorithm. Unlike the standard PSO, our version uses the dynamic pruning. If a feature's like how it works is if a feature's selection frequency falls below a threshold of 0.12 for more than 6 iterations, it is removed. This is a stability-based focus approach, which allowed us to identify the 17 most discriminative features, such as the subflow backward bytes and init forward bytes, etc. Once these features are optimized, they enter our CNN by LSTM attention-based pipeline. In this pipeline, there are several steps, and I'll go through one by one. The first step is spatial feature selection, feature extraction, which is a 1D CNN layer which extracts local associations from the packet data. Then we employ a bidirectional LSTM. This is crucial because it captures the traffic dependencies in both forward and backward directions, providing a fuller context to the attack flow. And then there's an added additive attention to ensure the model doesn't get lost in the data. The additive attention mechanism underlines the specific flow segments most relevant to identifying the threat. So, and then the output is processed through a dense layer with a 0.5 dropout rate to prevent the overfitting, resulting in the final attack likelihood. So after this, after we got the results from this complete output of this pipeline, our results highlighted the importance of our final step, which is the threshold optimization. Most models use a default 0.5 threshold, but in high-stakes security, false negatives are far more dangerous than false positives, which is our case. So, by maximizing the F1 score on the precision recall curve, we have identified an optimal threshold of 0.0403. This calibration improved our accuracy to 94.1%. You can see the comparisons here, and has successfully identified the 3,193 attacks that the standard threshold would have missed. While this increased false positives slightly, it is a necessary trade-off for protecting the critical infrastructure. So we have done a broader related work research survey to compare our work with the existing. So there are certain points that have highlighted our works, which is the hybrid model of CNN LSTM with the dynamic PSO combination. And the most works ignore the threshold optimization. So to conclude my presentation, in summary, our research demonstrates that by combining an advanced feature optimization with hybrid deep learning, we can achieve high sensitive in DDoS attack detection. So, as our future works, looking ahead, we aim to explore the model quantization to further maximize the performance on research constrained edge devices, which is our ulterior motto. So, yeah, thank you for your time. And now I welcome any questions, if any.
Yes, Venkat. Am I audible?
Yeah, you're audible.
Yeah. Why you choose CNN? Why not other?
So, why we selected the hybrid model is your question. Am I right?
First of all, let me know the CNN. What is CNN? Why you
Okay.
choose the CNN?
So
After that, we'll go
that's
for
the first step. We have used the CNN to attack to extract the local spatial features, like identifying the patterns within the individual packet headers and the flow statistics.
Okay. Now, how you include this CNN with other ones so that you are calling it as a hybrid?
Yeah. So yeah, as I have said in my presentation, we have created a complete pipeline. Like the data passes through the CNN role, which the CNN, which has a role to extract the local spatial features, and then we pass it to the BiLSTM, which is used to capture the temporal dependencies. Like we are using the BiLSTM as, but it is capable to do both the forward and backward direction, which ensures that the model understands the full context of the traffic.
Okay. You have mentioned in that feature reduction. What is that? 80 features?
So like 80 plus features actually. So 80 plus features are the features which we have in the original data set, the CIC DDoS 2019, which I was mentioning.
Yeah.
Yeah.
Yes.
Isn't that the question?
No, what is that 80 features? What kind of features it is? In what parameter you are getting? Features means what?
Oh, okay. So they are the features which are like this data set we have took it from the Canadian Institute of Cybersecurity official page. So basically, they are simulating the DDoS attacks, and these 80 features are describing the attack structure. Like I have said, using the init forward bytes and backward bytes. So,
Okay, Venkat.
yeah. Thank you for the opportunity.
Thank you for your presentation, Venkatu. Next up, we have SM Mazharul Chaudhary presenting the paper titled Gamified ADHD Interventions Through Human-Computer Interaction, a thorough study of BCI, AR, and cognitive training games for children with ADHD.
Hi, can you hear me?
Yes.
Okay, give me a minute. I'm going to share my screen. Okay. Hi, everyone. My name is Assam Mazharul Chaudhary from University of North Texas. Today, I'm going to present a paper titled Gamified ADHD Intervention Through Human-Computer Interaction, a thorough study of BCI, AR, and cognitive training games for children with ADHD. The question that drives this paper is, can the tools we associate with entertainment, such as video games, augmented reality, brain control interfaces, can be designed to serve as a legitimate clinical grounded therapy for children with ADHD? Here is the structure of our study. We started with background understanding of ADHD and why existing treatments like clinical treatments or medication fall short. Then our research question and methodology. The core of this presentation is a deep dive into each of the 6 games individually that we studied, because each one of them is a distinct and instructive example of HCA in action. So let me explain why this work actually matters. ADHD is one of the most common neurodevelopmental disorder in childhood. It is defined by 3 core symptom cluster: inattention, hyperactivity, and impulsivity, with direct measurable consequences on academic performance, social relationship, daily functioning, and let's say long-term emotional stability. Current treatment each carries significant limitations. For example, medication tend to produce only short-term improvements and raises concern about side effects during clinical development periods. Behavioral therapy create adult dependency for the children that performs better when they are guided, but don't develop self-regulatory skills needed to function independently. So there are certain limitations for each of these treatment, but our gamified system that I'm talking about, it is actually performing much better. It can actually perform much better than traditional treatments like the intervention fails. The other intervention that you can call traditional treatments, they fails because it's not cognitive. It's not actually. I'm so sorry. It's failing because they are not something like not effective. But the thing is, the treatment don't last very long. Um, but human-computer interaction-based treatments fundamentally chooses a defined path. For example, HA is the science of designing technology around the psychological needs of its user. When you apply that design psychology to the profile of children with ADHD, their need for novelty, their responsiveness immediately changes, and it produces good result for the children as they are interacting with the computer or a system that is designed to improve their attention and social activity. So our review was structured around two questions. First, to what extent do HCA and gamification-based approaches, specifically serious games, BCI, and AR environments, help develop cognitive and behavioral interventions for children with ADHD? And notice that this is not simply asking whether those tools work or they don't. We are asking through what mechanism they actually work, under what design conditions, and how different choices produce different therapeutic outcomes. Secondly, what are the common design patterns? What are the limitations and future possibilities across recent studies? This is this is a synthesis question. It pauses us, or it actually focuses toward the individual paper and identify what this body of work reveals collectively, what I'm sorry, that no single study could show on its own. Together, those questions orient the review toward both effectiveness and insight toward understanding the field's current state and its most important gaps. To address these questions, we conduct a semi-systematic literature review designed to be transparent, structured, and replicable. Our research spanned different sources and renowned publishers covering papers from 2010 to 25. Then this 15-year window captures the full arc of modern ASA development in this space, from early computer-based system through to today's AR and BCI applications. Inclusion required papers to be peer-reviewed, to involve an actual gamified ADHD intervention with participants, to engage meaningfully with HCI design principles, and to present empirical findings or a detailed design evaluation. On the exclusion rule, we remove non-interactive tools, review-only papers, studies without any case data, studies focus only on diagnosis, and any study whose participants fall outside the age range of 6 to 12 years. Before going deep on each game, here's the full set at a glance. 6 games across 3 different distinct technology platforms, such as augmented reality in ICTIS and Bravo, mobile and PC series games in Bright and Antonyms, a camera-based emotion system in Emo Galaxy, and a brain-computer interface game in the BCI 3D game were studied. Participant numbers range from 8 to 11 in those studies that report exact figure with ages from 6 to 12. Each game targets defined cognitive and behavioral domain, executive functioning, self-esteem, self-regulation, inhibitory control, and so on. What unifies them is the design challenges they all share. How do you make cognitive therapy something a child actively chooses to engage with? Antonyms is an AR series game grounded in embodied cognition theory. Children navigate through real physical environment overlaid with digital challenges like planning routes or sequencing movement, solving spatial puzzles, training executive functioning through their body rather than a screen. The key finding of this are that task completion times are shorter than in traditional approaches, suggesting real-world spatial embodying reduces cognitive load. The therapy becomes indistinguishable from physical play. Bright is a mobile serious game built on Maloney's theory of instinct motivation. It targets self-esteem. the motivation foundation that makes all other cognitive training possible. Children take on superhero personal role, and then they receive personalized positive reinforcement, and then they experience adaptive difficulty that keeps them in the optimal challenge zone. The entire motivational architecture of the intervention is rebuilt around the child's psychological needs, not bolted onto existing training task. Bravo is a multi-session AR and VR environment guided into self-regulation and social cognitive theory, and it uses full body motion capture and effective agents. Virtual characters that respond to the child's emotional cues are included in here. What makes Bravo particularly significant is uh, its stated future vision. A unified cross-platform ecosystem integrating AR and VR and neurofeedback with effective agent was implemented in this game. And this vision anticipates everything we recommend in our future direction section. Antonyms is the most theoretical rigorous system in our review. It is grounded in the dual pathway model of ADHD and converts stoop and flanker clinical test into a woodland narrative game. The player must resist the most accessible leaf and choose a deliberate strategy, inhabiting control reframed as a story conflict. Critically, in-game error directly correlate with clinical performances measures. Entering is both therapy and a bonus assessment, and the intervention and the evaluation are the same activity. Immiglacy targets emotional regulation and social skill development. A webcam detects the child's facial expression in real time and feeds them into a snake and ladder mechanic. Positive regulation advances the player, and deregulation or their if they're not focused enough, it causes setback. Emotional becomes the controller in this game. The child cannot process without genuinely regulating their emotional state, turning an abstract therapeutic goal into a continuous practiced and miserable game skill. And for this game system, there were no variable required. The BCI 3D game uses an easy headset to read brainwave in real time. Measured attention level directly controls a virtual hand in a 3D game environment. To succeed, the child must neurologically produce and sustain attention, not just understand it. The child sees their own brain activity visualized on the screen, creating a feedback loop of genuine self-awareness no behavioral intervention can match. This is ACI at its most direct approach, and the mind is the interface for interaction. Now that we have seen all 6 games individually, I want to step back and look at what they reveal collaboratively. And when we analyze these 6 systems together across their very real differences in platforms, technology, and therapeutic target, 4 consistent conceptual themes emerge. And those are insights that give this body of work its collective significance, and that should guide the field going forward. The first and most fundamental insight from the study is the engagement in the system that is not designed feature added to make therapy effective. This is the therapeutic mechanism itself. Children with ADHD do not have a general attention deficit. They struggle to regulate attention when motivation is very low. Conventional cognitive training tasks are repetitive, abstractly, and clinically imposed. The child disengages before the benefit actually becomes reality. The treatment fails not because its target is wrong, but because the delivery system cannot hold attention for long. So HCI resolves this through 3 distinct mechanisms across our 6 games. Narrative games like Antonyms and Bright restructure the emotional architecture of cognitive tasks through story and reward, lowering resistance and sustaining motivation through meaning. In short, motivation drives sustained attention, which enables improved performance, which reinforces motivation among the children, and they keep playing these games so that the treatment becomes effective for their further progress. The second theme is about translation. Cognitive construct like inhibitory control, working memory, and emotional regulations are invisible and intangible to the child experiencing them. You cannot instruct a child with ADHD to practice inhibitory control in the abstract. SA makes those constructs visible, interactive, and practicable. Antonyms converts clinical inhibitory control task into narrative decisions. The child feels and decides rather than being told to perform. And games like Emo maps facial expression to game outcomes. Emotional regulation becomes a practice in this system and measurable game skill rather than an abstract therapeutic goal. Children engage in rigorous cognitive training without experiencing its clinical work, which is the precise condition under which training can be sustained long enough to produce real change. Our third theme traces a clear three-phase trajectory across 15 years of work. Phase one was screen-based cognitive training, clinically sound, but um, engagement is very limited. Children had to be made to comply. Phase two was the gamification shift, narrative framing, adaptive difficulty, reward system, and so on. Antonyms and Bright sit here designed as game built on clinical theory rather than training tools with games element added to them. The goal shifted from compliance to engagement then. And phase three is neuro-embodied and multimodal. That was reflected in the antonyms and BCA games and Bravo. Those systems engage children cognitively, physically, and neurologically, and emotionally at once. Each dimension refines the others. The direction is very clear, and from tools that require compliance to ecosystem that generate motivation. Our fourth theme is the honest accounting of what this body of work cannot yet tell us. Sample size are very small, 8 to 11 children across the studies that report exact figures. These are appropriate for pilot work, but far too small for establishment of generalization across diverse population. It is the symptoms and cultural context. No study was conducted more than a few weeks, and none conducted long-term follow-ups as well. We do not know whether observed improvements were precise or whether they transfer from control lab settings to classrooms and daily life. The absence of control group measures, control group means we cannot roll out the possible and novelty of participants rather than from the intervention themselves. And practical barriers remain such as easy noise, variable radiation in PC systems, expensive hardware for AR, and engagement decay over time. These are not reasons to abandon this
Excuse
research.
me, Mazharul. Sorry to interrupt you. This is just to remind you that 1 minute is left for your presentation.
Okay. So they are precise agenda for what next generation of studies must address. So some border pattern emerge across all 6 systems. First, feedback loops are universal. Every system uses immediate and coupled feedback as its core engine, whether based on performance, movement, or neural response or emotion. This is not a coincidence. And secondly, every system is grounded in established theory. For example, antonyms is dual pathway model, Bright is Maloney's in transit motivation theory, and all the systems have their established theory that they were following. That grounding is what gives them validity. Third, ASA is collapsing the boundary between assessment and rehabilitation as antonyms generates in-game data mapping to clinical measures, and BCA can produce real-time neural records, and this data can be actually used to understand the mental condition of a child or how we can improve them further. 5 priorities emerge clearly from our analysis. Large-scale real-world studies are overdue. Pilot evidence has done its job, and clinical validity requires far more than 8 to 11 participants. Long-term follow-up is essential to confirm whether improvements persist and generalize to daily life. And a hybrid multimodal system combined as like BCA systems, AR, CS games, neurofeedback, and effective agents like that. This ecosystem needs to be combined together to get a very good result that we understood from this study. And in conclusion, I would like to say that essay and gamification are theoretically grounded, empirical supported tools, not novel ideas. Engagement is the core therapeutic mechanism here, and understanding they should fundamentally shape further intervention designs. The field has evolved meaningfully from screen-based time training to rich neuro-embodied and multimodal systems, but small samples and short studies mean the evidence-based much catch up with the promise with a very large sample data, and this is the most urgent priority for this study. Here are some references and papers that we use for this study, and thank you everyone. If you have any question, you
Yes.
can ask me now.
Yes. How your system is different than the existing one?
Actually, it's a review paper, and we studied these 6 games. We didn't build any system yet. We're right now we are working on collecting data. For example, we are conducting some surveys that will give us some insight about what children actually need. For example, what kind of game they actually play. For example, all these studies, they have one limitation, that is, though they are diverse, very advanced, but they don't focus on children's psychological advancement or what they actually need. So we are working on something where we're collecting data from ADHD patients aged between 6 to 12, and based on this data, we're going to construct a system. Initially, we plan to create a game with 3 different type of strategies. One will shape their brain activity. For example, ADHD patients or ADHD children, the common problem is they cannot control their brain activity. So first game, it will control their brain activity. Second game is going to make them socially active. For example, it's going to be a online-based game, and they will be able to interact with other participants in the game. And like that, we'll be able to develop a better game that actually gives us good results.
Okay. Thank you.
Okay, thank you, Professor.
Thank you for the presentation. Now we have Nidhi Prithvi presenting their paper titled Objective Evaluation of YOLO Architectures for Crowd Detection.
Good morning, ma'am. I'm sharing my screen, ma'am.
Yes.
Ma'am, is the screen visible?
Yes, it is visible.
Okay. Good morning, respected session chair and everyone. The title of my paper is Objective Evaluation of YOLO Architectures for Crowd Detection. My name is Nidhi Pruthi, and my research supervisors and co-authors are Dr. Rajiv Singh and Dr. Swati Nigam. The outline of my presentation is as follows, starting with introduction, the related works, proposed method, experimental results and analysis, conclusion and references. Crowd counting and density estimation, they are the active research challenges even nowadays in the image and video analysis due to the complex nature of the crowd scenes. So both the crowd counting and density estimation are integral part of the crowd analysis. Like the crowd counting, the main aim of crowd counting is to understand the pedestrian flow, while the density estimation supports the critical applications like video surveillances, public safety, and intelligent transportation systems. The earlier methods mainly focused on the pedestrian detection, but still the performance declined due to the high crowd density or severe occlusions. With the rapid increase and growth in the field of deep learning, a significant progress has been achieved in both crowd counting and density estimation, even under highly congested scenarios. Developments in the field of density estimation are categorized into the detection-based, regression-based, CNN-based, and video-based methods. The increasing frequency of the large gatherings, like in concerts, parades, and the sporting events, it has further emphasized the importance of the reliable and the accurate crowd analysis for the safety and the management. In this paper, in our study, a unified and a systematic objective evaluation of three state-of-the-art YOLO architectures, namely YOLO V5, YOLO V8, and YOLO V11 is presented for the task of detecting the individuals, identifying the small groups, and large-scale crowd analysis. These models are rigorously trained and evaluated on four benchmark datasets, namely VS Crowd, Crowd Mall, Crowd 11, and NWPU Crowd, covering a diverse range of crowd densities, the different environments, and all the occlusion scenarios to ensure generalization and the robustness. The previous work, it shows that from the view of different types of network architecture, the authors have classified the crowd counting models. The head feature enhancement model is proposed, which helps the model to learn to recognize the head and the background features. The deep convolutional neural network based crowd density monitoring for intelligent urban planning uses the deep learning methods for crowd. The authors have also presented a model known as CrowdDiff, which creates the density maps as an opposite diffusion process. The proposed method is categorized into 2 points. The first is the selection of the model. The three versions of YOLO, the complete form is you only look once. The architecture YOLO V5, V8, and V11, reflecting the continuous advancements achieved in the detection of the objects, counting the crowd, and density estimation. Among them, YOLO V5 and YOLO V8, they are the well-established models which are widely used in detection of the objects, but YOLO V11, it still represents an experimental prototype. The key factors such as the crowd counting and density variations were considered when the model was evaluated. The data set includes the images from all the real world scenarios and all like walking, waiting, playing, and fighting both in the indoor and outdoor crowd environments. Based on the detection accuracy across the data sets, appropriate YOLO models, along with their different variants like S stands for small, M for medium, and L for large, they were selected for performance comparison. The schematic flowchart of the proposed approach goes as follows. The crowd images were selected, the images were annotated, and the pre-processing was done. And after that, the models, the YOLO training was being performed and the models were evaluated. If the certain accuracy was not achieved, again, the model was being trained on more data set and images. And finally, the crowd or the groups were detected. The second part of the proposed method is the data collection and the preparation. The data sets used in this study, they encompass diverse crowd settings taken from the different camera viewpoints and in the different environmental conditions. Mainly two data sets were employed. First is VS Crowd, and the second data set is a combination of these three benchmark data sets, that is Crowd Mall, Crowd 11, and NWPU Crowd, which were created to enhance the diversity and generalization. The data sets, they consisted of the video clips. The video clips were turned into the extracted frames depicting the different public scenarios like in marketplaces, pedestrian zones, and the gathering areas. The images were annotated and using the tool label image, and they were made in the YOLO compatible format. The annotation process involved generating the bounding boxes for individuals or groups and ensured the consistency with the YOLO's anchor box based prediction framework. Each image was standardized to a resolution of 640 cross 640 pixels to maintain the uniformity across all the experiments. Once the annotation was completed, the dataset was split into 80% of to the training and 20% for the validation subsets. These are some of the sample images that were taken, and the last image is the annotated. Is it in the annotated form? Next is experimental analysis. The experiments were conducted using the Google Colab notebooks equipped with these are the GPUs, the CPUs, and 13 GB of RAM. The first results on the VS Crowd data sets. So we trained and evaluated the three state-of-the-art models, V5S, V5L, and 8M on VS Crowd dataset, with the focus on analyzing that how each model performs in group detection tasks. V5S is the fastest and is the smallest of all the three models, but it performed reasonably well for detecting common classes like individuals or small groups.
Excuse me, Nidhi.
Yes, ma'am.
Sorry to interrupt you. This is just a reminder that 2 minutes are left for your presentation.
Okay, ma'am. I'll do it quickly. So the results showed that group 2 demonstrated a reasonably well MAP, but in group 3 and group 4, they just scored about 0.100 and 0.012 respectively. So the total MAP for this V5S was 0.443. After that, V5L showed a slightly lower individual performance and compared to V5S, but this model showed a noticeable improvement in detecting group 3. So the overall MAP was 0.440 for V5S. The diagrams are the training curves, the validation curves, and the confusion matrix. YOLO V8M showed a very clear jump forward. It not only retained a strong performance on the common classes like 0.799 AP for individuals and 0.722 for group 2. So the overall balance across all the categories led a standout of MAP at 0.535. So we found out that YOLO V8 was the best choice that actually dealt with all the understanding of all the fine crowd dynamics. So this is the training curve, the validation curve, and the confusion matrix. So that's the overall comparison, and it's compared with the benchmark. After that, another after that, another experiment was made on the crowd data set, and on that YOLO V5M, 8M, and 11M with the focus of analyzing that how each model performs. So in YOLO V5M, that's on the second data set, the average precision was 0.300. But for another class, that is group 2, it performed reasonably well, that is 0.569. So these are the training, validation, and the confusion matrix for YOLO V5M. 8M again showed us a similar type of performance, achieving the overall MAP of 0.306. YOLO V11M, again, the performance dropped slightly to 0.300. These are some of the output images on crowd dataset and VS crowd dataset. So the conclusion shows that the paper evaluates the performance of various YOLO-based model architectures on V5S, V5L, and 8M and 11M on the two crowd detection datasets. So out of all these YOLO architectures, we found that YOLO V8M displayed a highest MAP of 0.535 between our runs, exceeding YOLO V5S and V5L. Detection accuracy for the leading classes like individuals, group 2 and group was continuously strong, but the model had a limitation that while considering the smaller or the less defined categories, that is group 3, group 4 and group 5, they showed a very limited detection. With the agile strategies, we believe that our model can do even better detection in complex and the crowded environments. So these are some of the references that I've taken. Thank you.
Yes, Nidhi, good
Yes, sir.
presentation.
Thank you, sir. Thank you very much.
Yeah, one or two question.
Yes,
How
sir, please.
do YOLO architecture perform differently in crowd detection?
Sir, YOLO
How
is
do
yes, sir. YOLO
how,
is
yeah,
YOLO is a computer vision model which is meant for the detection of the single objects. So I've trained this model in such a way that if it can detect the groups. So like if I've annotated the images like two people of group 2, three of group 3, and I've trained the model in such a way that if it is able to detect the if it is able to detect the groups and it considers them as one single object.
then how you are going to compare to their performance in clean audio SAR task?
So sorry, sir, I didn't get the question.
Your YOLO architecture perform directly in crowd detection, right?
Yes, sir.
Then how you are going to compare to their performance in clean to ASR task? You are having ASR
No, sir.
at automatic speech recognition.
No, sir. No, sir. It's nothing related with speech, sir.
Okay, okay, okay,
Yes,
okay.
sir. Sir,
Okay.
yes, sir. Sir, I've
How
taken
your
the
system is
yes, sir.
how your system is different with the existing one?
Sir, sir, my research continues with the crowd behavior analysis. So, sir, I have taken I've taken various crowd dynamics. Like I have taken crowd and I've put on in my future work. I've taken the direction as well. Like if two people are walking in a similar direction and the distance between them, so I'm counting the distance between them, but if they are moving in a different direction but the distance is very less, so I've not taken them as one single crowd. So direction is, sir, another dynamic that is not been touched so far. So this is one point that I've put it into my future researches.
Okay, good work, ma. Keep it
Thank
up.
you, sir.
Best of
Thank you
luck.
very much. Thank you for your kind words, sir. Thank you so much.
Yeah.
Thank you, Nidhi, for your presentation.
Thank you so much, ma'am. Thank you.
Lastly, we have Arin Bansal presenting the paper titled A Transparent and Resource-Efficient AutoML Framework with Agentic Guidance and Meta-Heuristic Feature Selection.
Good afternoon, everyone. I am Arin Bansal. Okay, now I will be presenting.
Arun, please make sure that you finish your presentation within the allotted 10 minutes.
Okay. Uh, so today I will be presenting work on transparent and resource-efficient AutoML frameworks using agentic guidance and meta-heuristic selection. So I will briefly walk through the proposed framework, methodology, and results with the key findings that we have achieved. So here, AutoML has made machine learning more accessible by automating pipeline designs, including algorithm selection and feature engineering. However, there is an emerging tension. That is, despite the strong predictive performance, existing frameworks rely on computationally expensive black box optimization and assume cloud-based execution. This makes them comparatively impractical in resource-constrained offline environments. Here, as we can see, the key statistics that 95% accuracy has been achieved, or more than 95% accuracy has been achieved, but they take more time compared to what in offline mode due to resource being due to algorithm not being optimized for offline mode. Okay. Next, problem statement. There are three key challenges here. First is high computational overhead due to black box optimization methods like Bayesian optimizations. Second is limited transparency. These systems do not clearly explain why a particular model or a configuration is selected. And third is strong dependency on cloud infrastructure. Our goal is to address all three under strict CPU-only offline constraints. Existing approaches falls into three categories. Traditional AutoML systems are powerful but computationally expensive. Meta-heuristic feature selection methods are effective but usually used in isolations, while meta-learning approaches rely on learned model, which are often opaque. However, none of these combine transparency, efficiency, and offline execution in a unified framework. Our framework consists of 4 stages. First is pre-processing and extracting of data set meta features. Second is an agentic advisor layer, which uses rule-based reasoning to recommend algorithm and optimization combinations. Third is wrapper-based feature selection using meta-heuristic optimization under constrained budget. And final is model evaluation. The key idea is to reduce the search space using explicit reasoning before optimization. Here, agentic guidance refers to rule-based reasoning over dataset meta features. Okay. We extract properties like dataset size, dimensionality, and class imbalance and sparsity. Okay. Then based on these, we apply explicit rules. For example, high dimensional datasets may favor tree-based model with ASO, while imbalanced dataset may favor SVM with PSO. Here, PSO is a particle search optimization. Okay, this approach is fully interpretable and does not rely on learned surrogate models. Feature selection is performed using wrappers-based meta-heuristic optimization. We used algorithms like genetic algorithm, PSO, WWO, ASO. WWO is water wave optimization once more. All optimization is performed under strict constraint using fixed iteration buzzards and early stopping. And this is the optimization objective we are using. This ensures CPU feasibility in CPU-only environments. We have evaluated the framework using stratified 5-fold cross-validation and multiple independent runs. We use benchmark dataset including IRIS and Sonar, and there were two more datasets that we had worked upon, but due to space constraint, I have not added it in here. Okay. All experiments were conducted on a single CPU machine without GPU or cloud support. And you can see here the hardware constraint that we have kept during all of our experiments. And these were the results we achieved. The framework achieved competitive accuracy across all datasets. As you can see, for example, 98% on IRIS, 97% on cancer, and 88% on Sonar. It consistently outperforms random baselines while maintaining reduced feature subsets, as we can see from the graph. This indicates the effective search guidance under constraints. We conducted evaluation studies to isolate the contribution of key components. Removing agentic guidance reduces the accuracy.
Excuse me, Arun.
Yes.
Sorry to interrupt you. This is just a gentle reminder that 2 minutes are left for your presentation.
Okay. Removing agentic guidance reduces accuracy and increases variability, while disabling proxy evaluation increases computational cost without improving accuracy. This shows that agentic guidance is the primary contributor to performance. Here, my conclusion. So to summarize, we propose a lightweight AutoML framework that combines agentic guidance with meta-heuristic feature selection. The system is transparent, resource efficient, and operates entirely offline. This is a proof of concept, not the full system. I am still working on that. Okay, it demonstrates that interpretable reasoning can effectively guide AutoML under constraint. Thank you for your time. I will be happy to take any questions.
Yes, Arin, good presentation. One or two questions. What is the main objective of the transparent and resource efficient AutoML framework?
Yes, sir. Actually, the resource efficient AutoML framework is to make the ML algorithm on datasets of purely offline. So like everyone does not have a GPU with them, and in today's we need GPU for ML. If not, then it takes more than 2 days or 2 to 3 days to compute. So what I am working on is for students like me to make it available for them in a cheaper way without having to buy a new computer. They can work on their own old computer. And second is the transparent thing is to explain what is happening inside the black box of the AI. Okay, I get it that we can't do that during the calculation phase, but after the calculation, we can do it. We can use the present AI framework to explain what is going on, how each step was calculated.
Okay, Arin. Thank you very much.
Thank you, sir.
Thank you, Ren, for your presentation. And with that, we have concluded all the presentations for today. I'd like to sincerely thank all the authors for the excellent presentations and valuable contributions. On behalf of the organizing team, thank you for your continued support for ICTIS over the years. We look forward to welcoming you again at the 12th edition in 2027. You will receive your digital certificates within 2 working days. The publication process will be completed within 7 to 8 months, so kindly extend your cooperation with ICTIS 2016 during this period. I would also like to thank our session chair, Dr. Ganesh, for effectively chairing this session. As a token of our appreciation, we would like to present the certificate to you, sir. Would you like to share any closing remarks, sir?
Yeah, definitely. Thank you very much. Ladies and gentlemen, as we draw to this remarkable session to close, I wish to extend my heartful gratitude to all the participants and organizers who have contributed to the success of the 11th International Conference on ICTIS 2026. Over the course of this session, we have witnessed insightful presentation, stimulating discussion and innovative ideas that reflect the rapid advancement in information and communication technology for intelligence system. The diversity of the perspective shared today underscores the importance of collaboration across the disciplines, institutes, nation in the shaping the future of ICT. I am particularly encouraged by the enthusiasm and dedication of young researchers and professionals who have driving forward new solution to global challenges. Their work assures us that the future of the intelligence system will be both impactful and transformative. Let us carry forward the knowledge gained here, continue the collaborate and strive to apply this innovation by the betterment of society. With that, I formally conclude this session. I wish you all continued success in your research endeavors and look forward to meet again at the future edition of ICTS. Thank you. Thank you very much.
Thank you, Professor.
Thank you,
Have a good
sir,
day.
for your kind and encouraging words. I request everyone to please turn on their camera so that we can have a quick snapshot of this session. All right. Thank you, everyone, for joining today. I hope you all have a great day.
Yeah, Sanskriti, one request, please share that picture, the last picture you have taken.
The certificate?
No, not certificate. This one, you have taken that last
Oh,
photo, right?
the snapshot, yes.
Yeah, snapshot.
Okay, sir, I'll send it.
Yeah, thank you. Thank you very much. Best of luck, everyone.
Thank you, sir.
Professor, have a
Thank
good
you,
day.
sir.
Thank you, sir.
Yeah.
Thank you, sir.